When we discuss what life is, or where is life in the universe, are we alone in the universe, one of the things that it's important to realize is that there's a lot of place in the universe where life just simply cannot exist. Now, we take it for granted that out in the middle of space where there's no planets, no stars, only minimal amounts of dust, that we're not going to be finding life there. But there's an assumption that often goes along that where we find planets and stars, that we're going to find places where life can exist. And one of the ways astronomers have developed to talk about this whole topic is the idea of habitable zones. So when we go out and look at planets and we're asking the question, is life possible? One of the things that astronomers talk about is water. Can water exist on that? Because where water can exist, that's at least a minimal requirement for life. Now, life requires other things. Life requires an environment, or a planet, if you will, a host, or a place to host the life. Life also requires a lot of elements other than water. It requires carbon, nitrogen, oxygen. It requires uranium, thorium. An abundance of chemical elements need to exist. And so we can begin to ask the question as we go and look around other stars, we look in other galaxies, as we look around the universe, where is it that life might exist? Or in other words, where are the habitable zones, the places where life could inhabit? Now, typically when we talk about the idea of habitable zones, we are talking about where will a planet receive the right amount of radiation from its host star such that it can support liquid water. Now, if you move a planet too close to a star, the radiation it receives is too great. The planet's temperature heats up and it will evaporate all the water and there will be no liquid water on the surface. Move that same planet too far away from the star and the temperature drops too low because it's not receiving enough radiation, and all the water will freeze. Either one of those, where all the water freezes or all the water evaporates and dissipates into space, either one of those is outside the habitable zone. Now, when you're talking about stars, the habitable zone, or the location of the habitable zone, depends on the size of the star. A brighter star is going to have a habitable zone that is a little bit further out. A dimmer star is going to have a habitable zone that is much closer in. Now, for the Earth, or excuse me, for the solar system, the habitable zone is almost centered on the Earth's orbit. Its orbit is kind of right in the middle, where you could maybe move out to Mars, and depending on how the atmosphere is, it's possible to have liquid water. You might be able to move in close to about where Venus is, and again, depending on the atmosphere, you could envision scenarios where there's liquid water. Now, if we go to dimmer stars like M-dwarf stars, which astronomers have begun to find quite a number of planets around, the habitable zone moves closer in if you're just talking about liquid water. But other constraints begin to come in. What we also find is that as we investigate deeper, there are other requirements on a star, and actually there's requirements on where a star could exist. So if we step back and say, all right, let's consider the galaxy as a whole. Could all of the stars support life? Well, there are other considerations that come in. Planets or stars orbit around the galaxy. If we live in a galaxy like the Milky Way, there are spiral arms. Those spiral arms are places where the density of stars and the density of gas and other things is much greater. And so as a result, if our star, our sun, were to pass through one of these galaxy arms, it would increase the cosmic radiation. It would increase the number of stuff that's impacting our solar system. It's going to increase the potential of interacting with another star. And so you want to find a region where there are very minimal passes, or where a star in that location is going to have very minimal number of passes through the spiral arms. Well, it turns out that's determined by where the radius of the star is, or how far the star is from the center of the galaxy. So you can talk about a galactic habitable zone. If a star forms further out, it may have fewer passes through the arms, but by forming further out, there's not going to be as many metals like uranium and thorium and carbon and nitrogen, and so that's going to decrease the habitability of a planet. On the other hand, if you move a planet or a star where planets are forming closer in and ask the question, could it form there? Well, again, you run into other problems, such as the closer you get to the galactic center, the amount of radiation coming from the galaxy center increases, or the amount of radiation that impacts the star increases, and that's detrimental to life. We live in a region where we had enough metals for life to exist, but we're not so close to the center of the galaxy that we're subject to a greater degree of radiation. Similarly, you can talk in terms of galactic habitable zones. If we're outside of the plane of the galaxy, there's a plane of the galaxy and there's the bulge in the center. If our star is too far outside the plane, that also subjects us to more of that harmful radiation that's coming from the galaxy center. So even within our galaxy, there's lots of places where life couldn't exist because the requirements are not met. Now, it's hard to put exact numbers on where is the galactic habitable zone. It's a little easier with the habitable zone around a star where you're talking about where water can exist, because that's a little easier to model and a little easier to put tighter constraints on. But nonetheless, this idea that there are habitable zones where life is possible is a well understood and well accepted concept as we study astronomy and begin to ask the question, are we unique? Are we alone in the universe? And so what research seems to be indicating is that the more we know, the constraints on these habitable zones are getting tighter and tighter. And so while we're finding lots of planets, while we're finding planets around other stars, this is exciting research. I think it's a great boon to astronomy, but it also begins to highlight the constraints that life must, or the constraints that a habitat for life must meet in order for life to exist there. And in fact, when you put all of those constraints together, the case that a designer or a creator specifically fashioned the sun and the earth in the right kind of galaxy at the right distance from the center of the galaxy, placed Earth at the right distance from the center of the sun with the right kind of planets around it, that a creator fashioned all that with a purpose so that he could introduce advanced life on a planet like Earth, and that's why we're here as humans. So the evidence grows stronger that indeed a creator has fashioned and prepared a place for humanity.